All right, fantastic. Good morning and welcome to this week's edition of Boundaries Webinar Wednesdays. My name is Sheyi Shambore and I'll be guiding you through today's webinar. Normally we leave a minute or two for people to jump on, they may be arriving late, but this is going to be a really jam-packed webinar. We have a ton of content to show, and so I want to make sure we get started right away so that way we're not pressed for time. Just by way of housekeeping, again, on GoToWebinar, all attendees are muted by default. And so in order to avoid crosstalk. And so if you have any questions or feedback or things like that as the webinar is going on, you should have a GoToWebinar control panel on the right-hand side of your screen. You might have to click on a tiny red arrow to expand it out if it's collapsed. But you can click on that and type a question, in there, or type something in the chat section. I have two of my colleagues, AJ and Sevi, on the webinar with me that will be presenting. And so if you ask any questions during the webinar, we'll make sure to get to those at the end. And between, the three of us, we should be able to answer any questions you have, either on air right now, or also we can follow up with anyone that asked a question afterwards as well. The other big item with regards to housekeeping is that this webinar is being recorded, and so it's going to be available on our YouTube channel after the webinar. And so again, if you came in late or you want to refer to the webinar afterwards, the recording is going to be available for you. All right. In terms of an agenda, what we're going to cover today, we're going to review and demonstrate some of the big enhancements that are available in Creo 7, right? And so after an introduction, we will talk about some of these enhancements and topics. So we'll start off with a lot of the general interface changes and enhancements that are applied to almost everyone that uses Creo. And next, we'll talk about multibody design and how that's been added into Creo 7 and what the enhancements are there. Next, we'll then go into the generative items, so the generative design with the multibody integration, and also then the generative design exploration functionality as well. So we'll talk about both of those. And then we'll go into the fluid flow for Creo Simulate Live. So essentially the real-time CFD that's now available in Creo Simulate Live. And then finally we will hit on the stochastic or random lattices, for Creo Additive Manufacturing and what some of the improvements that have been made, in there. And then finally we will dive into a Q&A section afterwards. And so again, as the topics, as we go through the topics, if you have any questions, go ahead and type them in there, and when we get to Q&A, we'll address them as well. All right. So really quick, I'm going to introduce my colleagues, AJ and Sevi. They're both going to be demonstrating what's new in Creo in terms of the product demos, and so they're both on right now, and I'm really grateful for them, being here to help out with the webinar. All right, so just by way of introduction, really quick, about Boundary Systems. So we are a product development consulting company that is based out of Cleveland, Ohio, but really, sort of as the map shows, we have a global reach, being part of the PDS Vision group of global companies. And our goal is, we partner with, industry leading, technology companies to bring, the best solutions, to our customers. And so whether it's, PLM or CAD data management, or simulation, really anywhere, customers are in the product development, I guess, sphere, we have the tools, whether software or things like that, or the expertise necessary to help, help our customers achieve higher levels of success. All right. Again, just another, a slide about who we are. Again, we've won, many different industry awards, including the Inc. 5000 list multiple times, and have, a lot of major accreditations, from, PTC and other other software partners as well. And then again, this also just shows a highlight of a lot of the different software partners that we work with. And again, this is not an exhaustive list, and so again, this just shows our breadth of product knowledge and how we use any solution to help our customer get to their end goal quicker and better. All right, so introductions are out of the way. We'll go ahead and dive into some of the core changes in Creo 7. The first we'll talk about is going to be the interface changes and enhancements. So when it comes to Sketcher changes, some of the things that have been enhanced, number one is mirroring functionality inside of Sketcher. Historically, you could only mirror across the center line, but now in Creo 7, you can mirror across any linear entity that you already have in your sketch. Aside from that, they also modernized the display of the constraint icons, also increased the default line thickness. And so you can see in figure 1, it's easier to see, Sketcher lines, in Creo 7 versus in previous versions. And they also made some big improvements as well to the snapping settings in Sketcher as well. So other usability items, they now added the ability for you to view Sketcher constraints while within edit dimension. And so again, if you're editing certain dimensions there, you can, instead of just seeing just the dimensions and the numbers, you can also see, the constraint scheme that was used, and that can, convey the full picture of how a feature was made. When it comes to some of the core modeling enhancements, one of the things they've added is the ability to draft already drafted, curved surfaces, right? And so if I have a cylinder drafting into a cone, I can add a second draft feature on top of that, which will, essentially read in the prior draft, requirements and just redraft the new surface based off of that. And then next, you can also modify existing drafts on imported models. And so again, if you get a non-native, file, a step, an IGES or things like that from vendors or customers, you can still, modify and change and tweak drafts on there inside of Creo 7. Next is for absolute accuracy as a core enhancement, and so that is one of the new things that's been changed. Now the default models in Creo 7 are set as absolute accuracy with the accuracy values as shown. And again, absolute accuracy is something that's strongly recommended for multi-body design, and so now absolute accuracy is the default that new models in Creo 7 are going to be using going forward. Again, if you open a legacy model from Creo 6 and earlier, if it was created in relative, it'll still maintain its relative accuracy setting unless you change it manually. But any new model created from Creo 7 onwards will by default be set to absolute accuracy. All right. So next big change is going to be inside of sheet metal, where there's the improved the enhancement where you can now trim the edges of a shared form. There's now an option for you to check to do that. They also added some enhancements when it comes to the welding feature, where you can now where they basically enhance the display of how a solid weld is created in Creo 7, and you can see that in the bottom left corner in Figure 1, and also added some enhancements to the align draft connection as well. And again, also expanding the multi-body support to many different areas in Creo, including, in this case, sheet metal, which now supports multi-bodies, and also in the welding application as well. All right, so at this point, I'll pause right here, and I'll have AJ demonstrate, a lot of the new usability enhancements in the interface and everything that's new inside of Creo 7. And so I will pause real quick and pass it on to AJ to demonstrate that to you.
All right. So you shall see my screen now. All right, thanks, Shay. So, like you said, I'm going to show some of these enhancements made. So for our first thing, I'm just going to create a sketch over here and show some of the sketcher enhancements. So I bring this up here. So if I just draw some simple line segments here, you can kind of see the line is just thicker. And so if I complete my sketch, you'll see that the icons are also updated and it's thicker, easier to see, gives you more usability of it. Another one of the benefits was the mirroring. So with these segments all still selected, I can now mirror over things like reference lines, which is linear. I could also just kind of come in here and draw a line segment at, let's just say, this angle. Take all of this, not these two, mirror it. Oops, sorry, need to unselect that and mirror it about just a line segment, and it will put it there for us. So that gives us some more control over mirroring. Don't have to create a bunch of center lines anymore to do that. So I'm going to just cancel out of this now. Next thing we have is showing the extrude options. So if I, edit dimension options. So if I just look at this extrude 2, I can edit dimension. And now we have the capabilities of seeing the constraints used along with the dimensions. This gives us greater control, greater ease of just seeing our design intent without having to go in and edit definitions of things. And that is was shown in the configuration option in the slide deck, but it is right here, show sketcher constraint dynamic edit. You set that to yes, and you're able to see it. If I turn it to no, and come edit definition, we won't have the ability to see those constraints anymore. So you do have some control over that. Another thing we have, if I come back and sketch on this, are my sketcher constraint snapping options. So by default, if I right click in snapping settings, by default, we will have these two turned on, and that gives you the same control that you're used to if you've used Creo, where if you kind of go over any other features, you're able to snap to that line. If I come down here and turn off snapping settings and turn off snap to model geometry, now if I create a line segment, we'll see that no matter what I do, I can't intent select, I won't be able to select these references. But if I do come in and create reference lines, I am able to snap to those. So this will give you some greater control. If you have a very complicated part, you can kind of control your references. Another option though, is if I turn off or keep on snap to model, but turn off instant snapping and come over here, it'll instantly, you can still instantly snap to references. But if I come over something that isn't referenced yet, like this line segment, and just hold it there for a second, then it will let me snap to that line. So that is the difference between the two. The last setting we have is snap to grid. I'm going to turn on instant snapping, and if I come and turn on my grid display, we are now able to actually use the grid and model using the grid. So I can snap to, for example, just some of the points on the grid and model that way. So some of the snapping settings. The next thing I have to show, we just cancel out of this, is my draft control. So previously you were not able to redraft already drafted edges, surfaces that are cylindrical. So now inside of Creo 7, if I select my draft tool and select a cylindrical draft like this, and then set my draft hinge, I'm able to actually change the draft. So where this could also be really useful is if I open up a step model, a step file, sorry, and get rid of these two. These shouldn't have been there. And so this is just a step file. I can now come in and actually view the draft of my part. And so I can edit the drafts like that. Alternatively, or another application is I can take multiple curved surfaces, such as all of these. Select draft hinge, top surface, and I can view the draft that was already applied to these curved surfaces, all three of them, which was 1.5, and I can change it, change the direction, do as I want inside of my step file. Next thing I have is creating a new part. So inside of Creo 7, if I just create a new part, use my default template. There. And if I just come to File, Prepare, Model Properties, I see that I'm in inch pound seconds. And if I go to my accuracy and change it, we see that the default value is 0.00039 inches. And if I was in metric, to be 0.001 millimeters, that is the default. You can still change these depending on what you want. But the default now is absolute. Last thing I have to show is on the surface in terms of surfacing. So if I come to a freestyle, I now have the ability to align with draft. So if I just take this edge, the align dropdown now has the align draft option. So I can align with a curve, plane. And now we have the option to set the draft angle. By default, it should have been 10. And if you look at this edge is where you can see the changes. So the default will be 10 degrees. And so if I change this to something like 3, you see that edge changes. And now if I come over to the other side, click away, and just repeat, what we'll see is that Creo 7.0 will keep my most previously determined angle, so that 3, and it'll apply it to everything within that freestyle feature. So it will keep that 3 degrees, but I could come in here and change this to whatever I want to further customize it. And that is the base enhancements made. So I'm going to pass it back to Shai to talk about some more features.
All right, cool. Thanks, AJ. All right, so we'll move on to see here, multi-body design and some of the enhancements that have been made there. And so multi-body design, generally speaking, it's not something new. It's something that's been, around in the CAD world for a while. But generally speaking, Creo has not typically allowed multi-body design in a single part until Creo 7. And so now inside of Creo 7, you can define, multiple geometric volumes as individual objects within a single part, right? So we're not in an assembly at this stage. We're just in a single PRT file, right? And some of the benefits there is, it gives you more, flexible and efficient design workflows, right? Now you can, for example, use certain bodies as a design tool where you can, for example, design, a fluid cavity as its own body, and then the housing around that as its own body, right? But again, the reality is, you don't really want to, you're not manufacturing a fluid cavity. What you're manufacturing is the housing around it. But again, having multi-body now allows you to design that much more efficiently. And with multi-body as well comes features like being able to to merge and to Boolean subtract and to Boolean what's it called, intersect as well. Again all within a single PRT file, not going externally to an assembly. And so again, this has a lot of applications just within better design, better tools to design with, just from a design standpoint, but also when it comes to things like additive manufacturing, some of the simulation tools that we're going to see later on, and also generative design as well. This again gives a lot of flexibility to the designer. And so we're going to have my colleague Sevi demonstrate just some of the new functionality that's shown through multibody. And so I will go ahead and pass presenter to Sevi and have him show that real quick.
All right, thank you, Shai. Hello, everybody. So I am just going to be showing a little demonstration on how the additions to Multibody Design can improve your workflow. So one of the first things you may notice over in the model tree, by default, you will, similar to the materials tab added in Creo 6, there is a bodies tab you will have. By default, you'll only have one, and you can see that that is set to the default body by that little blue star there. Currently, we have one other, which is defining this pad shape right here. I'm just going to go ahead and hide that. So I'm going to go ahead and create an extrude here. And first thing I'm going to do with body options is I'm going to unclick remove material, and that will allow me to create a new body here. So what this means is whenever this extrude actually finishes creating, it is just automatically going to put it in a body of its own. You can see this has its own material, which can be customized separately, and the extrude included inside of it. So next, I'm just going to really quickly change the color, just so we can see the differences there in the bodies, and I'm going to go ahead and hide the rest of that. All right, so now that we have this body kind of isolated, I'm going to go ahead and perform some operations on it individually. One of the advantages here is that we don't have to, go into an assembly and then go back to the PRT file. We can just do this all very seamlessly. So I'm just making a quick sweep here, and I'm going to basically just modify this this part before I perform some operations on it. All right, first thing I'm going to do is just create a mirror of this. So I'm going to select this body. I can perform operations on entire bodies at once. I'm going to click mirror and just mirror that across that bottom plane. So next, you can see that this actually did create a separate body for that other half. So I'm going to go ahead and do a Boolean operation and merge them together. This is very easy, very simple, and I can quickly make these one body again and add that merge into body 5. All right, so last thing I'm going to do is demonstrate how we can actually use multi-body to simplify the design process by designing a body as a cavity or a cut or something along that nature. So essentially what I'm going to do here, I'm just going to go ahead and pattern this, this body I created. Let's see, going to just make 8 equidistant parts there. Switch around some references a bit. And voila. So now I have this body that is basically 8 different parts here. And I'm just going to perform another Boolean operation and subtract that away from the whole. So again, very simple. The subtract will just remove the whatever's included in one from the other. You can see I have a preview there. And voila. I found it's much easier to do something this way with multi-body rather than designing parts or or rather extruded cuts separately. So hopefully that shows some of the usefulness, and I'm going to throw it back to Shai.
All right, thanks, Sevi. All right, so you're seeing the demo of Multibody there. Next big topic we'll go ahead and highlight what's new is in terms of the generative topology optimization and design extension. And so the generative topology optimization, that is a functionality that PTC included in somewhere between Creo 5 and Creo 6, and it's also in Creo 7 as well. But it's the old solver and technology was fairly clunky, very poor UI, really tough to use. And so PTC essentially, purchased in a different company and developed that as a wholly owned PTC company. And instead of licensing the technology externally, they built this from ground up, right inside of the PTC code, which then means that, this is much more seamless in how it works inside of Creo. It also works with multibodies as well. Just as we were seeing earlier as well. Again, multibody has a huge application here inside of generative, and so again, you have very similar generative feature, but again with much more ease of use plus multibody as a result of the enhancement to Creo 7. In addition to that, there's also the generative design exploration extension that's going to be coming in Creo 7.02, so it's not available right now, so we can't show that to you. But you can almost sort of imagine, the figure on the bottom right over there in Figure 2. If I was going to, figure out, maybe for example, we have 10 different materials that we're potentially going to evaluate as options for manufacturing that part, and we wanted to see, okay, if we were going to additively manufacture this or mill this or cast it, what's going to be our best option, right? So all of a sudden 10 times 3, now I have 30 design alternatives to choose from, right? And so the generative design exploration is intended to, for example, in that case, run multiple design variations in parallel on the cloud, right? And then give you sort of an explorer web page where you can then view all your 30 different alternatives and then start to filter and sort between them. If you want to filter by, least stress, least deformation, filter by, least cost or things like that, you can start to filter out and figure, okay, out of these 30 alternatives, for, material versus manufacturing constraints, which one gives me, the best piece of best design right now that I can run with and make a product out of, right? And so that's what the generative design exploration is supposed to do. And again, that's coming in the Creo 7.02 release. And so we'll show the just the current topology optimization that's available right now, and I will pass it on to my colleague AJ to show that. So. AJ presenter.
Thanks, Shay. So you should all be seeing my screen now. Yep. So on my screen here, I have a steering stem, and what we're going to look at for the topology is these actual individual stems, and maybe we can explore through generative topology what a better model might be in terms of maybe our advanced manufacturing processes. So I'm going to look at just the base model here. And so through the use of multi-body design, we've created two parts: the envelope, which is the full model itself, and then the preserved geometry, which is what we're trying to keep. And so now the new part of generative design is this actual application. So if I turn this on, you'll see that I've already ran the simulation because it takes a bit of time, but it's a much more user-friendly interface. You can select starting geometry, preserved geometry, and excluded geometry, and you can select bodies for this, which is where multi-body design can really come in handy. After you set up what you're going to be performing generative design on, you would have to go in and create a simulation. So in my case here, I put a fixed constraint and some forces to run. Next point over is you just follow this along is design criteria. Here's where you're actually able to kind of go in and add things like limit my volume. Let's say I want to remove 50% of my volume. I can set this. Design constraints. So you can put in what manufacturing capabilities you're actually capable of doing. And this can help you define out how generative topology will help you. You can also put in geometric constraints. So again, further control for yourself over your generative topology design. And the final step would be to add in a material. So if I look down here, I can see my previously ran design criteria is I had a planar symmetry. So if you put planar in the middle here, on both sides is the same. That's a planar symmetry. I limited my volume to 67% of the total for the material. After you do design criteria, you would go into study settings, and here's where you can actually control how intricate your model gets. On the far left side of the slider, fidelity of 1, that will give you your model very quickly. However, it might be a little bit rougher, might not be as accurate, or you can come all the way to the detail, and it will take a lot longer to run, but you get much more intricate, because if you just kind of look, what it's doing as you drag to the right is it's decreasing your element size and increasing your maximum iterations. So that's what it's basically doing in terms of like meshing and fixing it all together. You can also kind of come in here and just type in maybe if you have preferred element sizes and how many elements you want to run. You can type those in instead of using the slider. It's up to you. After you do that, you would go in and run the optimization, which I've already done. It'll take a little bit of time. And after that, you can actually also even show your simulation results. So if I turn this to megapascal, you can just see our stresses on this part, this generated model. And we'd see that we have a maximum stress of 52.2 megapascal. And so we could use this to kind of see maybe this does not meet our design requirements. Maybe we need this to be 40 megapascal for whatever reason. That can be used as verification to see if this generatively designed topology design model is good. You can also turn on animate deformation, which will give a second to kick up. And so if I put this down here and play it, we'll see what our deformation looks like also. Close this. And then you could run generate or click generate design and actually create your model with these generative design changes. By doing that, you take this part model, which was your base model, and you can create new part models that actually have your generative topology in it. And if you look in the model tree, we have the generative design one that's created as part of you generating the model, and also a group reconstruction, which is the actual geometry from the generative design. So this is obviously an additive manufacturing process here. I also have a milled model made here. And from this one, if I come to applications, generative design, I can look at my left-hand side and see, yeah, I created a linear extrusion and gave it some direction. So basically telling generative design here that, hey, we only have milling capabilities. We don't have additive manufacturing. So you can still use this application for your manufacturing processes just by setting different design criteria. And that is all we have to show for generative topology. So I'm going to pass it back on over to Shei to talk about the next thing.
All right, cool, wonderful. Thanks, AJ. All right, so the next big bucket of functionality we're going to talk about is going to be Creo Simulation Live, or generally a lot of the ANSYS functionality that's being leveraged inside of Creo. And so for that, what I will first thing is going to be some of the core capabilities that they've added in Creo 7. And so one is they've added the ability to do transient thermal studies. Historically, you could only do steady state, but now they added transient. They added the support for multibody inside of Creo Simulation Live. Also some functionality improvements as well in terms of the ability to select a local coordinate system, and manipulate the direction vector as well as some, some legend enhancements and such. And then there's also the scope selection as well, which allows you to define your simulation scope. So if I have an assembly of 50 parts, but I only want 10 of them to participate in the simulation and see results on 10 of those 50 parts, I can define the scope inside of Creo 7 and say, hey, when Simulation Lab is running, only run on these 10 parts and ignore the other 40 on the screen. So again, you're given with the same computing resources you have, you can get much more accurate, much more focused results, right? And then the other piece of functionality that's been added, which we're not going to be able to show right now because it's going to be available in Creo 7.02, but that is the Creo ANSYS simulation feature as well. And essentially the Creo ANSYS simulation, that's basically going to be full-fledged FEA analyses, and so you can think structural, modal, and also thermal analyses. But again, the difference is these are going to be using the ANSYS solvers, and so these are going to be the ANSYS solvers and technology that's been developed over decades. It's now going to make its way into the Creo platform, and that's going to be the Creo ANSYS simulation enhancement there. Again, we won't be able to show that because that's going to be coming in Creo 7.02, but again, we'll show some things in terms of the Creo Simulation Live usability changes there. All right. Next, big bucket item that we're going to talk about is going to be when it comes to fluid flow for Creo Simulation Live. So essentially, CFD inside of Creo Simulation Live, right? And so what that's doing there is, we're looking at, either internal or external flow, right? And the ability to then, run, CFD right inside of CSL, all right? And so you can, display streamlines, you can put fluid particles in, you can have cut planes, but in this case, instead of, applying a force and looking for stress, you're saying, hey, I have air flowing or water flowing at a certain flow rate, over a certain geometry, let me know what my pressure drop is or things like that, right? And so again, this does not replace the full-fledged, Creo flow analysis, extension, which is its own analyst level, CFD tool that can handle much bigger, much better physics. This is just a very easy, quick and dirty, let me, with the quick gut check, if something is, good or bad, or, should I tweak it one way or the other? Should I make this dimension 8 or 9, and see how the flow is going to be impacted by that? This is more so for very, very quick and dirty feedback in terms of your CFD design there. And so I'm gonna pass it on to AJ and have him show a quick demo here of what all has been added to CSL.
All right. Thanks, Shay. So the first thing I'm going to show are just some of the enhancements made to simulate live simulation as a whole. So right here, you see we're in live simulation. I have a static analysis on this hanger piece. So first thing I'm going to do is just fix a surface. And so now the first thing we're going to look at, that's a big change, is the force load of application dialog box here. So if I come and put force on this surface, we now have the option of checking magnitude, direction, or directional components. We're going to keep this top option. And so if I want to just go down, put force down in Y, I put -1 here. And let's say the force can be 100 newtons. And if I press enter, we can see actually preview, which is another thing added to live simulation, is this preview of our load. But one of the bigger things they've added is the ability to select coordinate systems. So right now we are using the global or world coordinate system, the default. If I left click here, we can pretty much select a new coordinate system. And in this case, let's change the direction. And now you can put a force perpendicular to a surface easily just by putting in a new coordinate system. If I want to go back to my world coordinate system or default, I can select this, change this back. Because another option we do have is to select direction. So if I select this and what surface I want to go to, Creo is automatically going to pick up the direction I want. So if I come here, enter, and so the force is now normal to that surface. And to make it go the other way, I can just easily put in some negative signs here. And we have the force coming down on that surface perpendicularly. Now, if I run a simulation, we can look at the next levels of enhancement, which would be the legend. Oh, give it a second here. There it goes. So over on the right, our legend has been better outfitted so that we can quickly switch between results. We now have simple drop-down menus that can let us just switch between something like deformation and stress, for example. This drop-down gives us our, what units we want to be in. So if we want to go to KSI, we can do that easily. Another thing is the display style. By default, it's going to be surface, which is the most commonly used one, I'd say. But another option that's very useful that was a little bit harder to use in a previous version of Creo Simulate Live is the composite. This one actually lets you set a target area and control your bandwidth in the legend, so that maybe you have a very complicated part and you just want to see higher areas of stress. You can basically use this composite to limit what you're seeing. And again, use the draggers to just show how much of it you want to see. Come back to surface. Other things is we currently have banded display on. We could turn this into continuous also from within the legend by selecting this middle icon, and we get a more continuous showing, a little prettier of an image. We also now have the ability to select probes in sensitivity studies. So if I just create a max stress probe on my part and save it, I can now create a sensitivity analysis from my analysis tab. And what we're going to do is take this. And so what the addition is, if I click parameters to plot, I can now select my simulation probe. And I'm just going to do a few steps here. And if I click on compute and give it a moment, we actually get a plot showing us what's happening on that probe as we change the dimension. The number of steps you set will be the number of points you get. In this case, it was something simple. I just increased my thickness, so the stress went down as it went up. But you can get much more complicated with that. So you can use probes in sensitivity studies now within Creo Simulate Live. Next thing we have to show is transient thermal studies. So if I come and add a simulation, add a thermal, by default it's set to a steady state thermal. But if I do the study dropdown, we now have the option to turn on transient, and it updates your simulation tree to say it's transient. And we also get an initial temperature boundary condition. So I'm going to just go in here, apply a load here, and just run this simulation. And so we see what's added to the legend now is this timer, which is showing the time of the simulation. And so obviously as time goes to infinity, it's steady state. But let's say you want to look at the first couple seconds. We can actually set a time limit. So let's say 2 seconds, and we'll see the heating after 2 seconds on this hanger here. Another option we have is to turn on and off our simulation objects a lot more easily. It's just a big icon right in our toolbar. So it made that a little bit easier to turn on and off. And finally, you can also just turn on initial temperature. It's automatically applied to the component, and you can just type in your initial temperature of the part. That will update everything here. So that's your transient thermal analysis. Turn this off. The other thing we have here is our scope selection. So inside of an assembly, you'll also see the ability to select parts to actually run analyses on. So if I select on scope, I see I've only have this top part selected. And so now if I run a simulation with everything I have here, we will see that the simulation only shows the results on the part we have selected. And the last thing they've added to Creo Simulate Live 7.0 is the ability to add in our more defined constraints. So we get cylindrical, ball, and planar constraints inside of Creo Simulate Live now. So that is all the enhancements made to Creo Simulate Live as a whole. And now I'm going to show some of the flow analysis stuff. So the first thing I'm going to show is this electronics enclosure. And so I'm going to create a new fluid simulation study. And that adds in a new study here. If you look at the dropdown, it puts in everything it needs initially. But the first thing we're going to do is actually create a fluid domain. And for our case, we are going to basically set where it's going to be. So we're doing internal flow, so we're just giving it the casing. You can do your own boundary conditions. So just going to put some flow coming in here. And I'm going to define some outlet spots. Okay. And now with those defined, I can actually just click on simulate, click on my cut plane, and we can see the flow coming out. My study dropdown performance options, I have this set to go to speed so we can see everything here. And on our right, we see the actual real time that's passed. And so you can see we're getting flow over in this area, but maybe it's not as high as we'd want. Maybe we want more flow over here, some higher speed flows for cooling purposes. I could turn off my simulation real quick. I could come in here to my extrude one. And move it over to the right a little bit. Could also come in here, resume some features, and change our cooling fin geometry. So now if I run my simulation, turn on my cut plane so we can see the internals, we can see maybe how the flow gets around here. And you can see some higher flows get towards the back here, which is maybe what we're looking for this design. And maybe basically this live simulation, this real-time flow allows us to see how our changes are made in real time. Tell us the direction we want to make our changes, like Shay said earlier. So that's an internal flow example. Another one we have is external flow. So if I open up my little race car here, I can go in and do something similar in that I'm going to create a fluid simulation study. And this time, I'm going to create a fluid domain. I'm going to create an enclosure volume. So the way to think about this is basically I'm drawing around what it would be like a wind tunnel around my car here to define out the flow domain. Click OK, and we see it, just an enclosure volume here. Next thing you have to do is edit materials and change. So you're given these default materials by PTC inside of this package. You can create your own ones as you'd like. We're just going to use air though. Yeah, whatever. So now we have air, and we can see this in our simulation tree. We're going to put some flow onto our car. So we're going in X. And again, we have preview capabilities. Put some slip symmetry. Lastly, we're going to put some outlet here. And so now, if I run a simulation, we can see some external flow behavior. And right now, you can see my cut planes out here in the back. If I come to my selection filter and select fluid objects, I can actually move these fluid objects around. And so now we can see some flow over this. You can rotate, you can move directions. On top of this, if I just move this to the back again, I can add in streamlines. And so as you can see here, we have some streamlines being released. It comes to the start point of our fluid domain. So I can move it around as I'd like. Let's move this one up maybe. All right, let's move down. Also, if I click out here, click on the edge, and you could change how large this is. So make it a little bit more elliptical. You can also right-click, add streamlines, and now we actually have two sets of streamlines, so we can actually monitor lots of different points. So maybe we put some flow coming underneath the car. Might be a little bit easier to control with the 3D dragger, but I'm just trying to prove something here. So we get something like that. You can also right-click and delete streamline if you want to get rid of it. Go into your streamline options also, and you can just change the look of your streamlines. Maybe you can up the count, change how wide they are. Length, you can decrease maybe. Add some tail length. Whatever you want to suit your desired display of your streamlines there. And so those are just some of the examples of the flow analysis, both internal and external. So I'm going to pass it back on over to Shai.
All right, wonderful. Thanks, AJ. So next, we are going to move on and talk about what's new when it comes to additive manufacturing in Creo 7, specifically the stochastic or random lattices and the functionality that's been added to that. And so with regards to stochastic lattices, that functionality was added in Creo 6, and at the time it was added using the Voronoi algorithm, and that still works fine. One of the enhancements that's made to stochastic lattices as a whole, Voronoi or Delaunay, is that historically in Creo 6, sometimes the stochastic lattice did not always see and obey the hard model edges you had. So if you hadn't added any model edges, sometimes the stochastic lattice would not, create a beam in that location, for example. Versus now, just as a baseline, Creo 7 stochastic lattices will respect those hard model edges, right? But then the addition that they also added in terms of an enhancement is now using the Delaunay triangulation algorithm to generate a stochastic lattice as well, right? So again, so essentially users have two different lattice options instead of just one. The Delaunay triangulation algorithm, again, it's just an additional option that users can create their designs based out of, and then analyze to determine the performance of that. And again, a lot of these will have applications when it comes to medical, and also improvements when it comes to thermal analyses and also shock absorption as well. Just to give some examples. And so again, this is just a quick overview here of some of the improvements in Creo 7 when it comes to stochastic lattices. And so at this point, I'll go ahead and pass it off to Sevi to show a quick demo of that. So.
Okay, thank you, Shai. So you all should be able to see on my screen, here we have a stochastic lattice. This is actually a Voronoi lattice. So this functionality, as Shai mentioned, was also in Creo 6. But one thing you may notice, it does follow these edges all the way along very, very neatly and nicely, while maintaining the randomness of the triangulation. So I am just going to add a definition of this lattice real quick. First thing you may notice is when this lattice is created, it is done so by actually replacing a body. So this works very well with Multibody Design added in Creo 7. A body can just be selected and then in turn replaced with this lattice. Next thing we're going to look at is cell type. So options here includes just regularly constructed lattices of this sort. And lastly, shown on the far right here, we have stochastic lattices. You can see that Voronoi was selected. I'm just going to change this to Delaunay triangulation. Volume and bounding surfaces is selected, which is what is going to make sure that the edges have a solid lattice all the way across. Cell size last time was 10. I'm going to go ahead and change this to 15. Another thing you can actually do is just scale it up. So if I type 1.5, it will just automatically scale it up from 10 to 15. And lastly, this randomize button, if I am not happy with the way it randomly configured these triangles, then I can just repress it and it's re-randomized every single time. So I press OK and I let this regenerate. It will depend on your cell size, how long it takes. You can see that took about 5 seconds and now it looks really nice. If I put in a smaller cell size, the time will increase exponentially. And if I do a bigger cell size, the time will decrease exponentially. But you can see that this kind of pretty complex lattice can be generated in a very reasonable amount of time. So here we go. This is an example of new features of lattices, including Delaunay triangulation. And I'm going to throw it back to Shei for some final thoughts in the question and answer session.
All right, fantastic. Thanks, Sevi. So at this point, that's the end of all the different topics we're going to cover today. Notice we're just a little over an hour, and I think more so that speaks to the amount of functionality and improvements that PTC has added to Creo 7. And again, the list we went through over at the top of the hour is not even an exhaustive list. There's way more beyond just what we covered. These are just, again, the top, 5 or 6 highlights. So there's even more enhancements beyond these as well. And this was not intended to be a fully exhaustive webinar on that. And so at this point, we'll look at some questions and answers. So I'll pull up the questions panel here and see what questions we have, and I will moderate and potentially pass questions off as needed. Right. Okay. Okay. So there are 2 questions that are sort of I guess you'd say the same question asked differently. One says, is the live simulation function, is it part of the Creo-based package, or is it an add-on that needs to be purchased separately? And then the other question related to that is, is CSL included in all the Creo parametric, packages? And the answer to that is no. CSL is well. CSL is an add-on that's not included in the base package of Creo. Some of the other higher end packages of Creo might include CSL in there, but the base package does not come with CSL. What I believe does come with CSL, though, I do believe PTC has a free trial of CSL, and so I think if you currently don't have a license of CSL and you click on the live simulation button, I believe there should be a button for you to click on where it'll automatically request a trial license for, I think it's 30 days, and it'll automatically pull that on your computer. So if you close Creo, restart it, you'll have the CSL functionality and you can try it out for 30 days. I believe that there is that functionality. And so another question here is, when is Creo 7.020 expected to go live? So I would say as of this morning, I was from a PTC presentation, the time frame was somewhere around October of this year. But then again, things could change, depending on how the development cycle goes. But right now, as of this morning, I believe it was sometime around the October timeframe. Right. So another question is, see, with regards to bodies, are the operations similar to working with surfaces but not solid, not hollow? And so I believe that's referring to how, with surfaces or surfacing in Creo, you can, do a merge, for example, to merge surfaces together, and you can also then, subtract out the surface from a solid, or you can add, a closed surface volume to an additional solid as well. So that it sort of has those functionalities, but it's very different. So for example, some of the additions, is that, for example, in one single part, I can have 3 or 4 bodies, right? And design in the context of a part, and eventually when I want to break it off into an assembly, right, I can pick on body 1, right click and say create new part. Pick on body 2, right click, create new part, and do the same for all the different individual parts, right? That's something that you cannot do just if you were doing pure surfacing to do that, right? And so the surfacing, traditional surfacing has some overlap with using bodies to Boolean out, but the multi-body functionality does way more than just what the traditional surfacing does. Right. Yeah, I believe those are all the questions that we're going to go over right now live on the webinar. We're already, a little, over an hour right now, and I don't want to take much more of everyone's time. And so for everyone else who asked a question, we will make sure to follow up by email, and we'll definitely get all of your questions answered. Again, our contact information is up on the screen. If you have any questions about what you saw today, you can go ahead and email. Thank you so much for joining us. And again, you can look forward to next week for another edition of Boundaries Webinar Wednesdays. Thank you so much, and you have a blessed day. Thanks. Bye.